Hello again, it's me, surprise. So number 2 is asking you to design an experiment. And I have a sneaking suspicion that they're going to ask you this one on the AP exam this year. Because again, they're going to have to find some way so that you can't just Google the answers to the free response questions. And I think that having you design an experiment is an application of your knowledge. So you might see something very similar to this on the AP exam or the free response questions. Alright, so it says the active ingredients in many pesticides are chemical compounds that kill organisms such as insects, molds, and weeds. Proponents claim that the use of pesticides improves crop yields and thus protects land and soil by reducing the conversion of forest and wetlands to cropland. Opponents of pesticide use claim that pesticides degrade water and soil quality and that other modern agricultural techniques and practices are responsible for the improved crop yield in recent years. Letter A, design a laboratory experiment to determine whether or not a new pesticide, product X, is toxic to minnows, a small type of fish. For the experimental design, be sure to include all of the following. Okay, so they want you to state a hypothesis, describe the method you would use to test the hypothesis, identify the control, and identify the independent variable. Okay, so here's my thought process here. Here's my idea. We are going to take increasing concentrations of this new pesticide, this product X, and we're going to dose it to minnows and see what percentage of them die. We're also going to have a control where we don't dose the minnows with any of the new chemical, this new product X. Okay, so for the experiment, establish, and again, this is your own experiment. You can establish as many tanks as you want. You can establish, 10 concentrations, 15 concentrations that you want to test. Usually the more concentrations you test, the better your curve is when you graph it, but it also takes up more time and more money. Okay, so for my experiment, I'm going to establish 10 tanks of minnows. Usually, if you're doing these types of experiments, you have to give the minnows some time to adjust to their environment. So that if they do die at the very beginning, you can say it's not due to them just adapting to their new environment. So establish 10 tanks of minnows. Give the minnows time to I don't know what to say. Great. Give the minnows time to become comfortable in their new tanks. And for this, I'm sorry, 10 tanks of, you should probably say how many minnows each. So I'm just going to do 10 tanks of 10 minnows each. Okay, so after they become comfortable in their new tanks, their new environment, begin dosing the minnows with increasing concentrations of product X, because that's what they're calling it, product X. For example, the first tank receives 0.001 milligrams per liter of the product in their water. Increase concentrations from 0.001 to 100 milligrams per liter by a factor of 10 in each tank. It looks like I'm running out of space, so I'm probably going to have to flip onto the back. So what I'm trying to describe here is that I'm trying to describe we're going to have 10 different tanks, 11 if you include the control. And we're going to increase the concentration from this 0.001 to 100 by a factor of 10 each time. So the first tank is going to get this 0.001. The next tank will get 0.01. The next one will get 0.1. The next one will get 0, or the next one will get 1, and then 10, and then so on and so forth. Measure the number that die in each tank. And I'm going to flip onto the back of mine because I'm running out of space. So this is letter A continued. Alright, so we're going to measure the number that die in each tank, calculate the death rate as a percentage, determine the LD50 by graphing the data. Okay, so we've given them a description of the experiment that we would perform. And again, the more specific you are, the better it is. Okay? So they also wanted us, if you look back on here, describe a method you would use to test the hypothesis. We did that. We need to state a hypothesis, identify the control, and identify the independent variable. The hypothesis would be, and you have to state this in an if-then statement, would be if product X has a low LD50, then the product is extremely toxic to minnows. And again, this is just my experiment. You can have any hypothesis you want as long as it is testable. And when I say testable, that means that you have to have some way to test your hypothesis. You also have to state it in an if-then statement. Okay, so we did that. We stated a hypothesis, which is good. Okay, we need to identify the control and identify the independent variable. The control would be a tank of minnows that does not receive any product X. Okay? Alright, so we did that. We identified the control, and now we need to identify the independent variable. The independent variable is the concentration of product X, or the dosage. I know this one seems like a lot, but you're having to just generally create an experiment, and then you're having to give all these things that they want. All right, letter B. It says, describe experimental results that would lead you to reject the hypothesis that you created in part A. So the hypothesis that I created, if you read back here on the back, this is the hypothesis that I created. If product X has an extremely low LD50, then the product is extremely toxic to minnows. Okay? So that's the hypothesis that I came up with. Yours might be slightly different. So it says, describe experimental results that would lead you to reject the hypothesis that you created in part A. So in mine, I said if it has an extremely low LD50, then it's going to be extremely toxic. So if I obtained some results that said, no level of this is toxic, that would cause me to reject my hypothesis. If I got some experimental results that said no amount or no concentration of product X was toxic, then I could reject my hypothesis. Okay? Letter C, it says, describe one law that regulates pesticide usage and/or control of toxic chemicals in the United States. Okay, so you can choose. There are two different laws that you could choose. They only want you to describe one. The two different ones are, there's Toxic Substances Control Act, and then there's the Federal Insecticide, Fungicide, Rodenticide Act. Alright, so that one's called FIFRA. So you can pick either one. I'm just going to choose TSCA, and I'm going to say the Toxic Substances Control Act gives the EPA the ability to regulate the creation and use of toxic substances. It requires companies to perform toxicity testing. Okay, letter D says describe two agricultural practices other than those involving pest control that increases crop yields. Okay, so one agricultural practice that you could say is using fertilizers. Okay, I know it's not the best one for the environment. You can say using organic fertilizers like manure if you wanted to say that. Okay, so one agricultural practice could be the use of organic fertilizers such as manure. Okay, so I know that we don't really like synthetic pesticides because the runoff from them creates the cultural eutrophication kind of thing. All right, the next agricultural practice that you could use, you can say vertical farming, you can say hydroponic agriculture. There are a ton of different things that you can say. You could also say, I don't know if they would, I'm pretty sure they would accept this, is the use of GMOs. So you can pick your favorite and just describe what it is. So I'm just going to give you some examples here. Use genetically modified organisms, genetically modified crops. Let's see. Use vertical farming. Use hydroponics. So pick whichever one you like the most, or maybe you had another idea, and then just describe it. Okay? So hopefully you enjoyed this video. I know this one was a little bit longer just because letter A it made you design an experiment. So I hope that it helps. Let me know if you have any questions, comments, send me an email. Have a great day.